Hi guys. Okay, so we are going to be looking at today at the redox reactions. So what are redox reactions? Redox reactions are those reactions in which the oxidation and reduction is happening at the same time. And what is oxidation and what is reduction? Oxidation is basically loss of electrons and reduction is gain of electrons. Loss of hydrogen is oxidation, gain of hydrogen is reduction, gain of oxygen is oxidation, loss of oxygen is reduction. Okay, so when you lose electron, obviously there's going to be an increase in a positive charge, and that is going to be an oxidation. And similarly, when you gain electrons, there is going to be decrease in the positive charge, and that is going to be reduction. On the opposite side, there is a decrease in negative charge, then it means that that compound, or so that particular species has oxidized. And when there is an increase in the negative charge, that species has been reduced. Okay, so these are very basic general things about oxidation. There is also a concept of oxidation numbers. So increase in the oxidation number is going to be oxidation, and decrease in the oxidation number is reduction. So before we start with the oxidation numbers, I just want to look at the placement on the numerical on this number line of the oxidation and reduction and the oxidation numbers. So oxidation numbers can range from negative to 0 to positive. So when you go from the left hand side to right hand side on a number line, that is going from a negative to the positive side, and that's including the 0, that is going to be oxidation. But when you move from a positive to the negative side, including the 0, then that is going to be reduction, and that is for the oxidation numbers. Now, the substances that get oxidized act as reducing agent, and those substances that get reduced are the ones that act as oxidizing agents. Okay, so in other words, oxidizing agents take in electrons, and the reducing agents, they give away electrons. Okay, so here's an example. So one example is a simple one, gain of oxygen. So iron, when it attaches to oxygen, and this is an example of, rusting. So iron reacting with oxygen, giving you iron oxide, and that is that means the iron has got oxidized because it acquired oxygen. But not all the reactions involved oxygen and hydrogen. So we have to look at the electrons now. So this is an example where you see lithium reacting with chlorine, giving you lithium chloride. So here, lithium gives away one electron, but when you balance this, it really is two lithiums giving away two electrons. And this is going to form a positively charged lithium ion, and two of them. On the other hand, if you take chlorine and this chlorine is going to acquire those two electrons. So chlorine acquires a negative charge. So here, lithium gives away one electron and acquires a positive charge, and chlorine takes in one electron and acquires a negative charge. So therefore, lithium is oxidized and chlorine is reduced. Lithium, on the other hand, it oxidized, but it is acting as a reducing agent because it gave away the electrons. Chlorine, on the other hand, acquired those electrons, therefore it is acting as the oxidizing agent. So keep that in mind, that oxidized, if the species that get oxidized is actually a reducing agent. The species that get reduced is actually acting as the oxidizing agent. Now, we've been talking about the oxidation numbers. So let's look at this. This is the bookkeeping of the electrons. In other words, we're just trying to figure out where exactly are the electrons. Have they left the atom or are they still with it? So what is the situation? So the bookkeeping of the electrons is now at a very finer level. We are looking at the activities of the electrons. Okay, so oxidation numbers are pretty much like the valence and the charges. So it's just pretty much that, but there might be a few exceptions. So one of the exceptions is, as you can see, the oxidation number of all elements in a free state, that is 0, means that this literally means that the electrons are not moving. So it's a neutral atom in which there is a positively charged proton, negatively charged electrons, same number, that is why it is neutral. Okay, so the oxidation number when the atoms are not combined, then it is 0. Oxidation number of diatomic molecules is 0 because these electrons are tied up, in a bonded state, so they are not available, you can say that. So the oxidation number in a bonded state in a diatomic state is 0. So as you can see, the examples H2, O2, Cl2, N2, all of them have their oxidation numbers 0. Okay. Next is the oxidation numbers of hydrogen is always going to be +1, except when hydrogen is with a metal hydride such as sodium and hydrogen. So in that case, when sodium hydride, in that case, hydrogen's oxidation number is -1. The oxidation number of oxygen is always going to be -2, except that of a peroxide. And that peroxide is like H2O2. So oxygen will always have -2, but if oxygen is in H2O2 state, it is going to be -2. Then comes the oxidation numbers of all group 1A elements. Group 2A elements is going to be +1 and +2. Oxidation numbers of all group 7A elements is always going to be -1. But there are exceptions. It can be +1 if hydrogen is attached to another element that is more electronegative. And chlorine is also attached to another element that is more electronegative. So for example, HOCl. So in that case, chlorine will have a +1 charge. Then the oxidation number of non-metals, such as group 6A, is always going to be -1. However, there are exceptions. Sulfur can have +2, +4, and +6 as well. Then the oxidation number of non-metals is always in 5A is going to be -3, except phosphorus, it can have +3 and +5 as well. Okay, generally the oxidation numbers relate to the charges for the polyatomic ions. Okay, before that, generally they relate to the charges of the element. So for example, in the case of iron oxide, so the oxidation number of iron is +3. In the case of tin 4-chlorosulfide, the oxidation number is tin +4. Okay, the total number of oxidation number of each atom in a neutral compound is going to be 0, and the total number of oxidation number of each atom in a polyatomic ion is 0. Now here's something I want to tell you. You do not have to actually memorize all these. If you can just remember, the free state means like uncombined state. For example, as it's shown, copper is 0 always if it is not combined with anything. Iron just by itself is 0 oxidation number. Zinc is aluminum, sulfur, all these will have 0 oxidation numbers because they are not in a combined state. So just remember a few things here. Chlorine, Cl2, diatomic, M2, O2, always is going to be 0. Just remember that. Hydrogen always +1, oxygen always -2, and these exceptions are there. As you can see, we already discussed that. So for the most part, oxidation numbers are really equal to the charges. Okay, so you don't have to memorize that much. But let's see. Still, there are going to be situations where you will not know the oxidation number and you will have to find that. So for example, let's look at this. Calculate the oxidation number of, let's say, H2SO4. This is given to you. And S. So like we said, S can have +2, +4, and +6 also. And it can have -2. So which one is that? How do we know? So let's put S as X. Oxygen, we all know. So here's your oxygen is always -2, and there are 4 oxygens. So 4 times -2, that's for oxygen. I'm going to just place it like this, sorry. Hydrogen, oxidation number is always +1. Then comes the sulfur, which is X. Then comes 4 oxygens, and sulfur is -2. And this whole thing is 0 because it is a neutral molecule, like it's not a polyatomic ion. So that is why 0. So now we have 2 plus X minus 8 is equal to 0. X minus 6 is equal to 0. 2 minus 8, 2 minus 8. So this is 6, and then X is equal to +6. So that's the oxidation number of sulfur. Okay, now let's look at it in sulfate. What is that? SO4, 2 negative charges. Okay, so this is a polyatomic ion. So again, the oxidation number of sulfur, X plus 4 times -2 is equal to -2. All right, so the sum total of the oxidation numbers of every single element in a species is going to be the equal number of charges for polyatomic ions, and it's neutral for a neutral molecule. That's why. So X minus 8 is equal to minus 2. X is equal to minus 2 plus 8. And this becomes X is equal to positive 6. So in this case also it is positive 6. Okay. Next is the, this one would be, next is, let's look at another example of ClO4 1 negative. So this is perchlorate. So in this case, for chlorine, let the oxidation number be X. So X plus 4 multiplied by minus 2 is equal to minus 1. X plus 4 2s are 8. So this becomes minus 8 is equal to minus 1. Okay. So X is equal to minus 1 plus 8. And this X is equal to positive 7. So that's the oxidation number of chlorine in perchlorate. Okay. So this is the way, this is how you will be calculating the oxidation numbers. Now let us look at those scenarios in which we are going to find out which of the element is getting oxidized, which element is getting reduced, which element is acting as an oxidizing agent, and which one is getting is not acting as the oxidizing, or in other words, is a reducing agent. Okay, so here's the situation. You have, let us say, iron. One example, here you have iron, and this iron as a solid is reacting with chlorine, Cl2, as a gas. Okay, and this is giving you FeCl2, and this is a solid. Okay, so the question is, identify which of the elements got oxidized and which one got reduced. So what are we doing here? We are going to, let me write this down completely. It is FeCl2, and this is a solid. Okay, so here we see that iron, the oxidation number of iron is equal to 0. And here the oxidation number of iron is equal to its charge plus 2. Okay, chlorine, because it is in a diatomic state, oxidation number is 0. Here there are 2 chlorines, which is fine, but each is having a -1 charge. Okay, the charge on the chlorine. So that's what it is. So what do we see now? We can just put these separately, and we can put here iron is going from 0 to a positive 2 state, and chlorine Cl2 is going from a 0 state to a -1 state. Okay, so when iron is going from, so that means iron is actually liberating 2 electrons and chlorine is taking those. Okay, so we see here that iron will be getting oxidized because it's moving from a 0 to +2 state. So this is oxidation. Iron got oxidized, and since it is oxidized, it is acting as a reducing agent. This is the guy that supplied the electrons. So in short, we can look at it as he was a troublemaker. And this guy over here, chlorine, when it acquires, when it accepts that 1 electron, chlorine can only accept. So then it got reduced. So we have, this is chlorine acting as a oxidizing agent. Okay, because it's accepting those electrons. Okay, so this is one scenario where this is going to be asked. Now here we are going to look at it. How do we balance this? So iron, okay, makes iron +2, and it gives 2 electrons. Okay, and here you have Cl2, and this becomes the Cl -1, but it's going to accept those 2 electrons. So really we are balancing it. We are balancing it like this. So 2Cl -1, and this chlorine is going to actually accept those 2 electrons. So let me just put it this way. Plus 2 electrons it has accepted, and here it becomes 2Cl with 1 negative charge. So that's the balancing in this case. Okay, so let's look at it another example. Okay, so now let's look at this reaction where lead oxide is reacting with ammonia and it's giving nitrogen, water, and lead. And you've been asked to balance this oxidation reduction reaction. So what are the steps? The first step always is to identify the oxidation numbers of every single element that is in the species. So here we have lead and oxygen. So a few things you always know. Oxygen is always -2 except in a peroxide. But if oxygen is -2, then the lead is also going to be -2 because this is a, sorry, the lead is going to be +2 because this is a neutral molecule. Okay, now here, ammonia, nitrogen belongs to group 5A. So the charge is -3, and hydrogen belongs to group 1A. So the charge hydrogen is always going to be +1. Now, this nitrogen is in diatomic state, the oxidation number is going to be 0. This hydrogen always is going to be +1. And here the oxidation number of oxygen is -2. Lead is in a free state, the oxidation number is 0. Okay, so what we see here, what electrons are gained and lost? So we see that in the case of lead, look at this, in the case of lead, and I'm going to just extend it a little bit, lead is going from a positive state to all the way a 0 state here. So lead has, in other words, lead has lead from a positive state to a 0 state means that lead has gained 2 electrons. From a positive +2 state to a 0 state means it has gained 2 electrons. Okay. On the other hand, look at nitrogen. Nitrogen, on the other hand, has gone from -3 state to a 0 state. From a -3 state to a 0 state. So that is, sorry about that. Sorry. Okay, so here we have -3 state to a 0 state. Okay, so in this case, it has lost 3 electrons. Okay, so nitrogen has lost 3 electrons. That is why it has got a 0 charge. And on the other hand, lead has gained 2 electrons. So now we need to balance those electrons also. So how do we balance them? We are going to multiply this 2 by this 3 by 2, and here we are going to multiply by 3. So in total, this becomes 6 electrons, and this is also becoming 6 electrons. But if that is the case, then we need to balance the multiply the where it's coming from. So we are going to multiply. So let's just do the second step. Here we are going to multiply 3 with lead oxide and, sorry, it's PbO, not PO. PbO, and we're going to multiply 2 to the nitrogen ammonia. Okay, and since nitrogen, the other nitrogen is balanced, we don't need to add 2 there. Okay, and then we just leave the water for now, and then we are going to add 3 to the lead also. Okay, so this 3 applies to lead on both the sides, and the 2 applies to nitrogen on the left hand side because it balances the nitrogen. Basically, it's in the end, it's all balanced. So now you look at what are the remaining that are not balanced. So obviously hydrogen is not balanced now. There are 3 leads here, 3 leads here, 3 oxygens, and there's only 1 oxygen here. There's 2 nitrogens, and again, the 3 hydrogens there, and there's only 2 there. So in fact, there are 6 hydrogens, 6 hydrogens this side, and there are 3 oxygens. So in order to balance that, we are going to put 3 in front of hydrogen. Okay, so that makes the hydrogen also 6. So 6 hydrogens, 3 oxygens, 3 leads, 2 nitrogens, 2 nitrogens, 3 oxygens, and 3 leads. So that balances the whole equation. So this is how you are going to be balancing the redox reactions. First, always find the oxidation numbers based on the oxidation rules, and then look at how many electrons are being lost and gained, And if they are not equal, then you have to find a common multiple, such as in this case, where we multiplied it by 3 and 2 to get 6 electrons. And if you multiplied the electrons that were gained by a certain number, the same number applies to that element as well. And the same goes for these electrons that were lost. So you have to multiply those numbers, and this is how you will be able to balance the redox equations. Okay, so I hope that was easy, and thank you for watching. Bye-bye.